This is question 4 of this applied trigonometry that we're going to do. And there is one thing that most people haven't learned yet. There's one trig identity that you have to know to be able to do this question. Now, on the formula sheet you're given as you go into the exam, one of the identities that's given, it looks just like this. I pulled this off the formula sheet. It says that the sine of 2 times an angle is equal to 2 times the sine of the angle times the cosine of the angle. So if you see sine of 2 alpha or 2 theta or anything like that, you can replace it with 2 times sine alpha cos alpha. So we're going to use this identity here. We're going to use it in the question. In fact, I might even take a picture of it here. I'm going to pull that over and I'm going to put it in the next slide because we're going to use it. I'm going to put it up here because we have to use it to figure out the problem. So there it is. I'll just put it at the top. We're going to use it down in here in this question. Now people find these questions pretty darn tricky, but just you're given this in the formula sheet and we're going to have to use it to solve these problems. But the rest is all just grade 11 trigonometry, you know, the things we're supposed to have known from before. Well, here we've got this picture here. We got PSQ, a right angle triangle. We got QSR, a non-right angle triangle, an obtuse triangle here. But these two angles are theta here. They're equal. It's an isosceles triangle then. Two angles equal. And there's the same angle theta there. Here's the side K. And here is the side, long side P. Now, all of these kind of applied triangles, when you're doing this applied trigonometry like this, look, there's no numbers. It's all variables. It looks a little scary. But the key to them always is there's a link between these two triangles. So we're going to start off, we're going to do QS. And we need to figure out something with K. Well, there's K, there's QS. K is opposite, QS is adjacent, and opposite over adjacent would be the tangent of theta. In fact, that's our first step. That's exactly what we do. We go K over QS is the tangent of theta. It's a right angle triangle. Now we're supposed to figure out what K equals, so let's multiply by QS, and we'll have K equals QS times the tangent of theta. That's our first step, and that's quite a big deal, just being able to do that. Now, we're going to work with QS, and we have to work with P, and somehow there's theta in here, but it's the law of sines we're going to start with, we're going to do. The law of sines says that QS goes with this angle theta here, so we can go QS over sine theta. Well, it will equal P, but hey, we don't know what this angle here is, QSR. We don't know that angle. But all we have to do, because we know these two angles are theta plus theta, they add up to 2 theta. The whole triangle has to add up to 180. That means this angle QSR must be 180 minus 2 theta. So all you do is go 180 minus these two other angles added together, and you'll always get the third angle. So P goes with the sine of 180 minus 2 times theta. Well, that's a big mark there for setting up that ratio. Now we want to figure out with QS. Remember I told you QS is the key? We want to get QS by itself. We multiply by P by sine theta, and ooh, look at that, P sine theta, that's what we're trying to get anyways. But now you have to know, if you have the sine of 180 minus any angle, it's to give you the same answer, it's in the second quadrant, and it'll give you the sine of twice the angle. That's just a thing you have to know about. If you've got the sine of twice an angle, or the sine of any angle, it'll always equal the sine of 180 minus that angle. So we can forget about the 180 minus, just write sine of 2 theta. Now it's time to use this identity. You know, like if we say sine, we know in grade 11 we can replace tangent with sine over cosine. Well, it works that way too. In grade 12 we've got an identity. If we see the sine of 2 theta, we can rub it out and put 2 sine cos theta. 2 sine cos theta. Oh, but look, sine theta over sine theta, that cancels. And you just have QS is equal to P over 2 cos theta. Well, now we've got a way of writing QS. It's P over cos theta. So let's just substitute that P over 2 cos theta in there, and let's see what we've got. We rub out the QS, and we put in P2 cos theta, and we get K equals P tangent theta over 2 cos theta. Well, we've got the P over 2. Somehow tangent over cos equals sine over cos squared. Let's see why it does. Well, tangent, we know from grade 11, we can replace with sine over cosine. Now this part here, all this is you've got sine over cosine, you've got sine over cosine, and we're talking theta here. But on the bottom, there's really cosine theta over 1. Cosine theta, and we could think of it as being over 1. So what do? You tip this upside down, and it becomes 1 over cosine, because you're dividing by it, and then you multiply. Well, by the way, there's a 2 and a P here as well, but you just multiply. You tip in time, so the cos times cos gives you cos squared. Well, then you've got your final answer. That's what we were trying to prove. K equals P times the sine of theta all over 2 cos squared theta. Well, you might need to go through this a couple times and be real careful. I only used one grade 12 thing, and that's this sine 2 alpha is equal to 2 sine alpha cos alpha. I had to use it here. The sine 2 theta, I had to replace it with 2 sine cosine like this. And once I did that, the signs cancel, and I got to my answer. But it's pretty tricky, this stuff. Remember, the secret is QS is the place where you start. You work with QS first in the right-angled triangle. Then we use the law of sines in this other triangle. Okay, hope that helped.